Hey Opties! Today we're going to be doing some practice with interior angles and exterior angles of triangles. So let's go ahead and take a look at number 1. In triangle ABC, find the measure of angle B if the measure of angle A is 40 degrees and the measure of angle C is 45 degrees. Okay, so it's telling me that I have some triangle ABC. So the first thing we should do is draw a picture with our given information. It doesn't have to be exactly to scale. I'm just drawing a triangle, and let's call it A, B, and C here. Okay, so now let's fill in our given info. We're wanting to find the measure of angle B, so let's just put a question mark here. And the measure of angle A is 40 degrees, and the measure of angle C is 45 degrees. Okay, so what do we know about the interior angles of any triangle? We know they are supplementary, which means they add to 180 degrees. So here's what we can say. I'm just kind of showing you the long way to set it up. The measure of angle A plus the measure of angle B plus the measure of angle C is 180. You wouldn't have to write this out to solve this. You could just add these together and subtract from 180, which is essentially what we're going to end up doing. But I just want to show you some substitution here just to make it very clear. The measure of angle A is 40. We want to find the measure of angle B, so let's just keep it like it is as its little variable here. And let's add it to 45 and equal to 180. So you know how I just said we would add our two given angles and subtract from 180? Well, right now we're going to add those two angles. So 40 and 45 is 85. And we're still adding the measure of angle B. And then we have 180 degrees. Now let's subtract. Now we're doing the subtraction like I said. 85 from both sides. That way we can get the measure of angle B. So 85 minus 85 is 0. So the left-hand side is just simply measure of angle B. And 180 minus 85 is 95. So you can see that this picture's not very to scale, right? Because a 95 degree angle, well, if that's one of our sides of our angle, going like this directly vertical to this horizontal side of the angle would be 90. So it would open up a tiny bit more than 90. So it would really look kind of more like this, our triangle, where this is a 95, and that's B. So you can just realize that if you're just drawing it just to get the picture of a triangle in your head or on your paper, it doesn't have to be to scale. As long as you know how to use the tools, it's okay. Let's take a look at number 2. Find the measure of angle E if the measure of angle E is equal to 3x plus 15 degrees, the measure of angle D equals 12x plus 30 degrees, and the measure of angle F is 7x plus 25 degrees. It doesn't say anything like we have triangle DEF because it's given us a picture, okay? So, let's do it 2 different ways. One way is the supplementary method, which works for all triangles. So here's what I mean by that. The interior angles of all triangles are supplementary. But what we're going to do next is look at it like it's complementary method, because if this angle D is 90, like we can see here, then we know the sum of the angles E and F has to be 90, because what's 90 plus 90? It's 180. So that's going to be the second method. Let's go ahead and do our supplementary method. Let's write 3x plus 15 by our angle E, and by D it's going to be 12x plus 30. And F, it's 7x plus 25. Okay, so we're going to add them all up and equal to 180. So 3x plus 15 plus 12x plus 30 plus 7x plus 25 is equal to 180 degrees. So let's combine our x's. 3x plus 12x plus 7x. Well, 10 and 7, 17, 18, 19, 20, 21, 22. So 22x, let's add our numbers or our constants now. 15 plus 30 is 45. 45 plus 20 is 65, and another 5 is 70. So plus 70, and that equals 180. Now let's continue to solve for x. We will subtract 70 from both sides. That's a 0. Let's continue over here. We've got 22x equals 180 minus 70 is 110 degrees. Now we'll divide both sides by 22. And x equals 5. And that's a 1 with the 22 divided by 22. Okay, we want to find the measure of angle E. So we're not quite done. Let's kind of go up here for a little room purposes. So the measure of angle E is 3x plus 15. So let's substitute our x value. 3 times 5 plus 15. That'll be 15 plus 15, which is 30. And since it's an angle, it's going to be degrees. So that is our final answer for number 2, and we did it with a supplementary method. Now let's take a look as if we're working it as it's complementary. And that is only due to the fact that angle D is 90. Again, if angle D is 90, then E and F are complementary because 90 plus what equals 180? 90. So E and F, the leftover pieces, if you take out this angle D, have to be equal to 90 when you add them together. So really, there are almost like 2 ways you could do this complementary method. Here's one way. You can find x by just setting 12x plus 30 equal to 90. Because you know it's 90, it's got the box there, right? Little box in the corner tells us it's 90 degrees. You can also add up 3x plus 15 plus 7x plus 25 and equal that to 90. I am not going to do both of these. I'm just going to start with this first one. I think it's probably a little easier. It looks like it might be quicker because you don't have to combine like terms right here. So let's do that. Let's subtract 30 from both sides. 12x is 30, 40, 50, 60, 70, 80, 90. That's 6, right? 60, not just 6. Divide both sides by 12. And x equals 5. Hey, it should equal 5, right? Didn't we just find that x equals 5 for our supplementary method? Yes, it's the same problem. We should get the same x value, okay? It's just a different method. So it doesn't matter what method you use, it's just whatever you like best. But if you are going to use the complementary method, make sure that you are able to do it. And the reason you know that is because you'll know it's a right triangle. If it's not a right triangle, it won't work. And you'll need to use a supplementary method that works for all triangles. So let's finish up. And if we were going to finish up, but we don't have to because we just did it up here, we're still finding the measure of angle E. So we would still find that by substituting our x value of 5 into the expression 3x plus 15, which will be 30 again. So 3 different ways really. 2 different mindsets, but the second one with the complementary, there's really 2 routes you can take to do that. Okay, let's look at some exterior angles practice. Number 3 says, in a triangle, an exterior angle is 125 degrees. One of its non-adjacent angles is 95 degrees. What is the measure of the other non-adjacent angle? That's part A. Okay, let's draw a triangle. We'll extend this side to the right to make this exterior angle, which will be 125. And then one of the non-adjacent angles, either this one or this one, is 95. So let's just say this one. Again, it's not to scale. This is obviously acute, right? But it doesn't have to be to scale. It's really about location for these types of problems, okay? So we know that the exterior angle theorem says that the 2 non-adjacent, let's call them A and B, are equal in measure to the exterior angle that's non-adjacent to them. So let's call that C. So the measure of angle A plus the measure of angle B equals the measure of angle C. So the measure of angle A is the non-adjacent angle that we don't know the measure of, and that's what we're trying to find. So let's keep it like the measure of angle A. The measure of angle B is 95. And the measure of angle C is 125. Really, if you're getting the hang of this, and if I wasn't showing this to you the first time, all I would do is 125 minus 95. That's really all you're doing, okay? So measure of angle A is going to be, once you subtract 95 from both sides, so 125 minus 95 is 30 degrees. So we're done with that one. The non-adjacent angle, the other one, is just 30 degrees. B says, what is the measure of the adjacent angle? Okay, so it's talking about this angle right here, the one that's adjacent to the exterior angle. So all you have to do for that one, let's call that D. We're still using the same picture. Those two are a linear pair. So the measure of angle C plus the measure of angle D is 180 degrees. The measure of angle C is 125. Measure of angle D is that adjacent angle we're trying to find. So we'll subtract 125 from both sides. That's a 0. And the measure of angle D is 55 degrees. Let's take a look at number 4. In triangle GHI, exterior angle J is drawn from extending segment IH, where angle H is the adjacent angle to angle J. The measure of angle J is 3x plus 17 degrees. The measure of angle I is x plus 5 degrees, and the measure of angle G is x plus 15 degrees. Okay, so the first thing we need to do is draw ourselves a picture. So let's draw a triangle. It doesn't have to be to scale. We don't know the angles yet, so there's no way for us to really make it to scale, right? And let's do G, H, I. So it says if we extend IH, where angle H is the adjacent angle to J, okay, blah, blah, blah. Let's just start with extending IH. So if it says IH, then that probably means start at I and go to H and extend in that direction. So if we do that, we're going to run into this H. So what we're going to do is just kind of rewrite our H here a little bit above. How about here? Because when we extend it, that's I. Here's how we extend it. So we've extended IH, and that makes this be J right here. So let's fill in our algebraic expressions. The measure of angle J is 3x plus 17, and I is x plus 5, and G is x plus 15. Okay, these are the two non-adjacent angles to this exterior angle J. So this is the angle J we're measuring. This is another one, another angle we're talking about, and this is another. So we'll put different arc marks to show they're not congruent, just to show which ones we're measuring. So if we add up G and I will equal to angle J. That's the exterior angle theorem for triangles. So let's do that. X plus 15 plus x plus 5 equals 3x plus 17. So x plus x is 2x. 15 plus 5 is 20. And then we have 3x plus 17. Let's subtract 2x from both sides. And then we have 20 equals x plus 17. Let's continue over here. And if we have 20 equals x plus 17, we can subtract 17 from both sides. That's a 0. So then we have 3 equals x. And that's the value of x. That's all we wanted to do for part A. Let's look at part B. Find the numerical measure of angle I. So the measure of angle I is x plus 5. If x is 3, we'll substitute 3 plus 5, and that means it's 8, and it's 8 degrees. So we really did have, that would have been a really small angle in our picture, because 8's really small, right? Let's look for C. Find the measure of angle H. So the measure of angle H, that is going to have to come about after we find the measure of angle J, because you have to figure out this out so you can subtract from 180. Or you could go ahead and say it's going to be 180 minus whatever J is. So we can just go ahead and set it up like this and then substitute our X, and it kind of can do it in one whack. So we'll do 180 minus 3 times 3 plus 17, because 3 is our X. And then we have 180 minus 9 plus 17. And that's 180 minus 26, which is 154 degrees. Okay, that's the measure of angle H. That would be this guy, so we can see that's really not to scale either. That would be a big old obtuse angle. All right, that is it for practice with interior and exterior angles of triangles. See y'all next time.